Hey class, we're back again working on decomposition reactions. This time we're talking about nitrates. So what would be an example of nitrates? Well, anything that ends in an NO3 would be a nitrate. Something like, something like KNO3 would be a good example of a nitrate. Notice it ends in NO3. Okay, that's what a nitrate is. So the nitrates of the alkali metals decompose on heating to yield nitrates and oxygen. Okay, now this alkali metal means, again, the same as it did before, it means group 1. So we're talking about group 1 metals. That would be lithium, sodium, potassium, rubidium, cesium, and francium. So they decompose on heating to yield nitrites and oxygen. So that means that if potassium here, which it is a group 1 metal, that means I'm going to write the same thing on the right hand side. I'm going to go KNO, but instead of, because of the nitrite, instead of the 3, I'm going to write a 2, and then plus oxygen, like that. Okay, so that means that my products are potassium nitrite plus O2 because of Brinkelhoff. Please don't forget O2, as in the 2 from Brinkelhoff. So then I have to go back and bounce the equation. How do I bounce this equation? I have 3 oxygens on the left-hand side, and I have 2 plus another 2 gives me 4 oxygens on the right-hand side. When I run into something like this, I just start doubling things. And when I double things, I end up with 2 Ks, 2 Ns, and 6 oxygens. So I got 6 oxygens here. So I put a 2 in front here to get 2 Ks, 2 Ns, and now here I have 4 oxygens, and then plus another 2 gives me 6. You see how when you double things, it just ends up working out. So I got 2, 2, 1 for the reaction. Well, what happens if you don't have an alkali metal? What happens if it's not a group 1 metal? Well, all other metal nitrates decompose to give us nitrogen dioxide, oxygen, and metal oxide. That's 3 products. So let's start off with the first one. So this is lead. Lead is not an alkali metal, so I'm going to write down NO2, that's nitrogen dioxide, there's the di part, 1 nitrogen, 2 oxygens, plus oxygen is O2, like that, plus the metal oxide. Now the metal is always the 1 in the beginning, so that's lead. Lead has a plus 2 because nitrate is a minus 1, so that means it's a total of minus 2, which makes this lead a plus 2. Okay, notice the subscripts on the outside of a parentheses, those are there because of crisscross. So you can see that that 2 came down from the plus 2. So that means I'm going to keep lead a plus 2 on this side, like this, and it says metal oxide, which means oxygen with a minus 2. So this ends up canceling. Plus 2 minus 2 equals 0. And now all I have to do is balance the equation. What I notice is that the 2 here for the nitrate on the left-hand side, I'm going to get rid of this stuff so I can show you. The 2 here means I have 6 oxygens and I have 2 nitrogens. Because there's no nitrate on the other side, I have to break them up into N's and O's. So, to do this, I have 2 nitrogens here, like that, gives me 2 N's. It gives me 4 oxygens here, plus another 2 is 6, plus another 1 is 7. Well, that is not good, because here I'm only going to have, any number I put in front here is going to be even because of that 2. So, that means I'm going to double stuff, because when I double things, things tend to work out. So I put a 2 here to get 2 leads, and then that means I have 4 N's, because 2 times 2 times 1 gives me 4 N's. 2 times 2 times 3 gives me 12 oxygens. Okay? Now over here, if I need 4 nitrogens, that means I need to put a 4 in front there. That will give me, instead of 4, that'll give me 8 oxygens. Okay? I need to put a 2 in front of here to get 2 leads. That gives me, come on, that gives me 2 oxygens here because 2 times 1 gives me 2 oxygens. So now I have 8 plus 2 equals 12 oxygens. How many oxygens do I have on the left-hand side? I have 12. How many leads? I have 2. Leads, 2. I have 4 nitrogens, 4 nitrogens. This was a tough one. This is a very tough, so that's 2, 4, 1, 2. Okay, 2, 4, 1, 2. That was a tough one. Let's move on and see what else we have. After nitrates comes carbonates. So what are carbonates? Well, we saw one already in the example as CaCO3. That's a carbonate. If it ends in CO3, it's a carbonate. Okay, so what's the rule for this one? Except for the alkali metal carbonates, all carbonates lose carbon dioxide, another prefix, and they form the metal oxide. Okay, so that means if I have a group 1, then it's a no reaction. Magnesium is a group 2, so that is, this one does work, and I do give off, so I do get as a product carbon dioxide, CO2 plus, and then the metal oxide. And the metal is always the first one, so that's magnesium. What charge does magnesium have? It has a +2, and the oxide is always a -2, always. So that means that these here I crisscross and get rid of the charges, and now all I have to do is go back and balance. So I have 1 mg on the left-hand side, 1 mg on the left-hand side. I have 1 carbon, I have 3 oxygens, I have 2 plus 1 equals 3 oxygens. So this one is actually balanced. Excellent. What's the next one? Sodium carbonate plus heat. What is our rule? Our rule is alkali metal carbonates do not react, except for alkali metal carbonates. So that means that this is a no reaction. All right, stay tuned for the last part of the notes, part 3. All right.